Okay. You can also do polynomial division with synthetic division. But this only works when the divisor is linear. Okay? So with the last problem, I could not do synthetic division because the divisor was a quadratic. So this one, the divisor is linear. So it'll work this time. So we're going to use synthetic division. It's just like synthetic substitution. Okay? We're going to set it up. But here's the thing. With synthetic substitution, you were told to substitute whatever number. So you were told what number goes outside the box with synthetic substitution. But you're not told that with synthetic division. So you're just given divide by this. So what number goes outside the box here? If you take x minus 2, set it equal to 0, x equals 2, that number is what you're going to write outside the box. So 2. And then you set up the little box. You list your polynomial coefficients. Okay, so let's see. Make sure I'm not missing any, and we're not. So 1, 5, -7, 2. I tend to space these out because if you don't, you might get confused. Bring down the first one. Start your multiplication and addition. Alright, so multiply, that's 2, add, multiply, that's 14, add, multiply, that's 14, add. Okay, so let me just check, make sure that's what I got when I did it a minute ago. And it is. Okay, so what does this mean? Okay, this right here is the remainder. This is the remainder. We started with x cubed, x squared, x, and a constant. Okay? Now, these are the coefficients on the quotient. We divided by a first degree polynomial, so we're going to reduce the degree by 1. So this is the coefficient on an x squared. This is the x, and this is the constant. And then this is your remainder. So the quotient, when you do synthetic division, the quotient is going to be x squared plus 7x plus 7 plus your remainder over x minus 2. So here is the quotient. So we use synthetic division. We're dividing the polynomial. We're getting, well, kind of a polynomial for an answer minus the remainder. If we don't look at the remainder, we're getting a polynomial for the answer. Okay? So that's the thing. When you divide by a first degree polynomial, your answer is going to be 1 less a degree. In the last problem, we took a 4th degree polynomial, we divided by a 2nd degree, and our answer was a 2nd degree polynomial. Okay? Alright. We're going to use synthetic division as much as we can, but again, it'll only work with linear divisors. The remainder theorem. Okay? Well, the remainder theorem, if a polynomial f of x is divided by x minus k, then the remainder is r equals f of k. What does that mean? Well, that means if you substitute k into your polynomial, whatever your final answer is, that's the remainder if you divide it. That's why we're able to do the synthetic substitution the way we are. Alright, so let's see. What is the remainder if this polynomial is divided by x plus 2? I've already set up the synthetic division to save some time. So now I'm just going to start my multiplication and addition. So 8 times -2 is -16. Add, I get -4. -4 times -2 is +8. Add, I get 14. 14 times -2 is -28. Add, I get -33. -33 times -2 is 66. Add, we get 75. So f of negative 2, if I were to take negative 2 and plug it in up here, I would get 75 for my answer. Okay? That's all the remainder theorem is. All the remainder theorem is that gives us the reason that we are able to use synthetic substitution. Now, we use the remainder theorem to kind of use to prove the factor theorem. Okay, the remainder theorem helps us prove the factor theorem. We're not going to prove them, we're going to use them. Okay, the factor theorem. This makes sense. If a polynomial, f of x, has a factor of x minus k, then f of k equals 0. So that just means the remainder is going to be 0 when you plug in k. So if x minus k is a factor of a polynomial, then the remainder is 0 when you do the division. Okay? So, and we can use this to help us factor completely, and we use factoring completely to help us solve. Okay? So let's say we can't factor something by grouping. Oh, here is a cubic polynomial. If I group the first two, I can factor out the x squared. But if I group the second two, I can't factor anything. So I can't factor this by grouping. But I've been told that this is a factor of it. So if that is a factor of it, then let's divide it and then see if I can factor the quotient. So that's what we're going to do. We're going to divide by 4, or by x minus 4 technically. So setting up your synthetic division, do the division. Okay, 4 times 1 is 4, add, that's a negative 2. Negative 2 times 4 is negative 8, add, that's negative 3. Your remainder needs to be 0, that's why that was there already. Negative 3 times 4 is negative 12. Oh, negative 12 and 12 is 0. Great, that means I did that part correctly and I copied everything right, so I'm good. The quotient is, this is an x cubed, so this is an x squared minus 2x minus 3. Now, does this factor? Okay, does this factor? Are there factors of 3 that will subtract to 2? Well, the only factors of 3 are 3 and 1. If I subtract them, what's my answer? Oh, 2. Yep, it factors. X minus 3, x plus 1. So, to factor this polynomial will factor completely. This quotient factors to this, so if I just throw the other factor down there, there it is. If I multiply these 3 numbers together, if I multiply these 3 binomials, I get this for my final answer. Okay. How else do we use this? Well, remember, factors, solutions, zeros, x-intercepts, they're all very closely related because they're all the same thing. We're going to use it to find zeros, okay? If I tell you, find the other zeros of f is a function, given that f of negative 2 is 0, oh, so that means, that statement there means that negative 2 is a 0 of this function, okay? Since negative 2 is a 0 of that function, I know when I do my synthetic division, my remainder must be 0, okay? So, I've set up the synthetic division. Okay, let's go for it. 1 times negative 2 is negative 2, that's 0. 0, 0. Add negative 9. Negative 9 times negative 2 is positive 18. Oh, yes, thank you very much. It did. Now, This is, remember this was x cubed, this is x squared, so this is going to be x squared, this is going to be x. So it's going to be x squared plus 0x, I'm not even going to waste my ink, minus 9. Okay? I'm finding the other zeros. So that means if I set this equal to 0, whatever this is, it must equal 0, so the other two zeros I can find. You can continue factoring. This is the difference of two perfect squares. You can factor it if you want to and set each factor equal to 0. If we did that, we're going to have x plus 3, x minus 3 equals 0, and x equals negative 3, x equals 3. You can do that. Or you can just add the 9 and say x squared equals 9. Square root both sides, so x equals plus or minus 3. Two different ways to get the same answer. You can factor, set each factor equal to 0, or in this case, just move the 9 over and square root. But when you square root and you're solving, you have to remember the positive and the negative.